Hello, everybody. Guillaume de Syon is professor of aviation history at the University of Albright in Pennsylvania. Here is the first episode in a series of 4 on the history of the space conquest. Today, the prehistory of space.
Hi, everybody. Welcome to this brief overview of early origins of space travel. Um, we all know about the general context of space travel, but in fact, there is a lot of pre-history of space travel that is worth considering. And so I'd like to tell you a little bit about it today. It's just going to be a brief overview. Basically, when you try to break down the prehistory of space travel, there are different ways of approaching it. I'd like to talk about 3 major themes today. One is sort of cultural settings, basically why the West. The second is take a look at some of the great pioneers, Tsiolkovski in Russia, Esnault-Pelterie in France, Oberth in Austria, then Germany, and then Goddard in the United States. And also talk briefly about the early German rocket program, although I'll talk more about the actual military program in the next session. So this will be the sort of the background to what I'd like to share with you today. The first question is, in some of the cultural setting, after all, knowledge of the action-reaction principle is understood, even if it's not clearly explained, already in the Middle Ages. The Chinese, with their discovery and use of black powder, have a chance to actually apply it, and in particular in these Mongol sort of bombardment cannons, for lack of a better word, where you see basically the black powder is loaded in there, and then the arrows are shot out. There's no sort of record of how effective these were, but they were used. So there was an attempt at military applications of that in the form of sort of early rockets. There is also sort of the very odd case, nowadays very popular online. You can see this, Google his name, of Wan Hu, who was a Chinese scholar, a Chinese official, who supposedly thought, well, what if we use some of these rockets to actually fly? And so the story goes that he had his assistants place 47 rockets beneath a chair on which he sat, and the rockets were ignited, and this is the last time Wan Hu was seen. Assuming that, of course, he had gone into space or something like that. Legend is not clear. We don't even know exactly when he lived. Some people say he lived at the start of the Common Era. Others say he didn't. He lived in the 15th century. Who knows? Later on, a few years ago, an American TV show actually tested the principle behind Wuhan's idea, putting a mannequin on a chair with 47 such rockets. And basically, the answer is that Wuhan likely either burned to death or exploded with those rockets. So it's not a very, very happy moment, but in popular culture, he's considered in a way sort of the first astronaut, if you will. Beyond the anecdote, we have to ask ourselves, if the Chinese have so much knowledge already in the Middle Ages, and this knowledge went far beyond anything Europe had achieved at the time, why is it that the Chinese did not go much beyond this? The short answer, and it's a bit simplifying, but still it's worth considering, is that China's science, in fact, allows it to explore, allows it to dominate the world, all the way until essentially what we call the early modern period, so 15th, 16th centuries. And then by 16th century, you have a shift in outlook. The Chinese are no longer, for example, interested in exploring. They're not interested in new technologies. And in fact, as of the early 17th century, China closest to the West, is not interested in new openings. It's very happy with itself, with its system. So why try to improve? Why try to explore in other directions? And so there's essentially what you have is a combined cultural and political reaction that rejects such new scientific endeavors. It's unfortunate, but it is part of the answer as to why it is that it is in the West that you see the first real interest in rockets. So with that in mind, let's focus a little bit on the West. The West was not bound to succeed. No, this would be a false claim of superiority. But 2 factors helped the West achieve what it did. in the 19th and 20th centuries in terms of air travel, but especially space travel. The combination of scientific and industrial revolutions are first to be considered. Put it this way, when both of these happen, starting in the 17th and concluding in the 18th century, and of course their impact carries on beyond that, the very fact that you have such revolutions means that you have a questioning of the world around you. You ask questions. You don't just say because and be quiet. You say why not, what if, okay? You see this in the political realm. For example, some very early histories, or rather, sorry, stories of going to the moon, okay? Or traveling and seeing sort of people. Think of Gulliver's Travels. Think of Cyrano de Bergerac, traveling to the moon in a winged ship of some sort. All that is not about, in fact, science fiction per se, but about questioning the political system. It's a challenge to the system. You have to add to this the fact that, for example, the church is, to the Earth being at the center of the universe. And so you can see why, with such challenges, you now have, of course, the notion that you could, in fact, explore further than what the established world says can be done. Okay, so that's one factor to take into account. As part of these revolutions, the fact is you have a trickle-down effect in the form of knowledge. Fantasy, like Gulliver's Travels, is transformed into science fiction in the 19th century. This comes from multiple facts. First of all, more people can read, more people can enjoy this. You have a popularization of reading, a popularization of science as well. If you think of, for example, Scientific American, the magazine that you can pick up and maybe you'll understand one or two of the articles nowadays. Well, Scientific American at its beginnings is about simplifying, in fact, it still is, advanced scientific discoveries for the general public. And the idea is indeed to make science understandable to all. Dozens of such magazines, such publications exist, okay? And in parallel, you have the appearance of early science fiction. Jules Verne with his famous From the Earth to the Moon. You have, of course, H.G. Wells talking about an invasion from Mars. This is science fiction. It's meant to entertain. Mostly boys happen to read it, some girls, but among the space pioneers, they are primarily young men. And they are going to be inspired by these writings, okay? And so with that in mind, we can then start to wonder, who are these pioneers? So there's several of them. You've got a Russian, you've got a Frenchman, you've got an American, you've got a Austrian turned German. No, it's not the start of a joke, I promise. Rather, it's a very interesting and unlikely combination. I'm not going to go at it in a proper chronological order, partly because scientific and intellectual ideas, in fact, have a way of sometimes inspiring, but sometimes also sitting around before being picked up again, or they are sometimes developed in parallel. So let's take that into account briefly. First of all, you have the Russian, Konstantin Tsiolkovski. Tsiolkovski was a math teacher, okay, and essentially sort of, while his, when he was not teaching and sort of, correcting his students' work, he sat around and started thinking of the notion of flight, okay. In the late 19th century, of course, there is a fascination with flight the world over. He actually tries to study it in a more formal way by applying his mathematical knowledge. Perhaps his most important contribution is this book published in Russian, Explorations of Outer Space by Means of Rocket Devices, 1903. And you can see notably some of the graphics that he uses with regard to this. Sorry about that. Let's see, where was I? I apologize. So you've got you can see that the process of evolution of his rocket. Initially, a sort of very simple action reaction with a pipe, and then the notion that in fact you should sort of mix these liquids in a certain manner or distribute them in separate chambers. In other words, you can see sort of this notion of the challenge of applying the Newtonian principle to travel into space with mass displacement and so on and so forth. Okay. Tsiolkovski, in fact, continues to write about aviation and about space. And then by about 1914, he stops writing about it. He loses interest in it, partly because he showed some of his models and got very little reaction to that. So he sort of moved on to other things. He was aging, so he figured he'd just focus on other matters. But still, these ideas that Tsiolkovski had will play a role down the road. Another fellow I want to mention is a Frenchman, Esnault-Pelterie. Pelterie is actually better known for airplanes, peculiarly shaped airplanes. He's one of the first to try and apply certain principle of aerodynamics and to early aircraft. He's only moderately successful, okay, as an aviation pioneer. In other words, it's worth noting him, but he doesn't produce anything, the way Blériot, for example, did. But in the 1920s, he becomes interested in this notion of how one could actually travel into outer space. In 1927, he gives an address at the French Astronautical Society, entitled "The Exploration Through Rockets of High Atmosphere and the Possibility of Interplanetary Travel." Wow, that's a huge title. But at least it says what he intends to speak about. The actual conference and then the later publication of the booklet is well received within specialized circles, but it doesn't have a big impact on the public. In the 1920s, the public is much more interested generally by grand exploits, traveling across the Atlantic, long distance airplane races, etc., etc. And Pelterie, in fact, is going to contribute this way through his suggestions in that conference and some related calculations. He's not going to do much more about it, but he will inspire some in the French space program. And so this is why he is worth noting, because of the sort of seriousness and the questioning that he put through in his 1920s intervention. So far, I've talked about two guys who, in fact, look at the theoretical side of things. Robert Goddard, the American, is, in fact, the first one and the only one of the four to really apply his scientific knowledge to actually testing a rocket. Okay. By his own admission, he was inspired by science fiction as a young man. He read H.G. Wells. He wondered whether one could travel. Then he went the academic way. He became a physicist, okay, and was teaching college when in 1926 he experimented with the first liquid-fueled rocket. Let me clarify briefly, and I'll show the slide. Sorry, here we go. To try and clarify this notion, when you see the Goddard's rocket, there's a model of it, a full-scale model of it at the Smithsonian in Washington, D.C. It's really sort of almost a downer. It looks like a little skeleton, sort of almost, not rusted, but certainly, kind of scrungy. Basically, this is the stand itself, and then the actual rocket is here, okay? But for the first time, Goddard tries to apply this principle of, mixing two liquids, okay? Oxygen and gasoline. Of course, you have the alcohol heater, but basically having the proper exchange, proper mix with the two valves so that you will have the reaction at the chamber and then the mass displacement. This is extremely important because very quickly people had understood that if you simply used solid, a solid fuel, okay, the principle of powder, okay, which is what a lot of rockets do still use today. Basically, you can control, the mass displacement to a degree. But basically, you just, burn it and that's it. You've basically run out of fuel. Okay, could you in fact control this motor? And so this principle that Goddard put together and tested in 1926 on a frozen lake in Massachusetts, not very far from Auburn. In fact, if you go nowadays, just look for the Auburn Mall, all those shops, and you'll see all of a sudden the casing of a big ballistic missile by the pond where Goddard tested his rocket. That's the monument they put there to commemorate that he had done this first test. The interesting thing with Goddard is that he's the first one to do this He's not particularly interested in publicity. He's very much into his projects, his science. So he would very much like to carry on. He is going to be helped in that sense by the American hero Charles Lindbergh, the first man to cross the Atlantic solo between New York and Paris in 1927. Basically, Lindbergh, very impressed by Goddard's rigorous application of scientific principles, is going to put in a good word for him to the Smithsonian Institution, who will give him a special grant that will allow Goddard to move to New Mexico to carry out his experiments in fair weather and also away from prying eyes. And he'll carry on these experiments all the way until his death in 1945. Interestingly, he's got over 200 rocket patents to his name. Most of these were granted only after he passed away. But this is why Goddard is very important. He is, in fact, the first person to apply these scientific principles to a test. The other person I wish to talk about is Herman Oberth. Oberth is an interesting fellow. He's originally from Transylvania, so what used to be Austria-Hungary, okay, and then had moved to Germany. Inspired by science fiction, he decided to try his knowledge, but in the form of a dissertation. So he wrote a dissertation about the principles associated with the needs for rocket travel. He especially tried to discuss what would be called sort of the principle of booster staging or rocket staging. Once a rocket acquires a certain speed, could you, of course, this has become empty weight, could you in fact have two stages, but what would it do to the speed of that second stage? Tsiolkovski had alluded to this. Oberth actually discusses it in even greater detail in his book, Die Rakete zu den Planeten Bäumen, basically the rocket going into space. And he was able to, through calculation, to suggest that, in fact, as the upper stage would fire, it would, in fact, acquire new speed. In other words, it wouldn't slow down. It would be able to rely on the speed already achieved with the first rocket. This is extremely important if you are going to go into orbit. Okay. Oberth presents this in the form of a dissertation at the University of Munich, and the thesis is rejected. This is far too crazy as far as the dissertation directors are concerned. And so basically he will never get his PhD. He will still publish his book. And anecdotally, it's interesting because a very young man at the time who was interested in space travel had seen this book advertised in a newspaper, and he sent for it. He ordered it. And as he recounted this story years later, this young man at the time was Wernher von Braun. He opens the book and he is absolutely crestfallen because there's nothing but mathematical formulas in that thing. And this is what essentially prompted Wernher von Braun to actually take his studies a little more seriously. So this is where Herman Oberth is quite important in that sense. He also tries on the theoretical level to apply some of his knowledge. I've essentially focused on these four pioneers. There are others, but these are the four main ones. And I've done this from the 1890s to the 1920s, skipping over World War I. Let me talk about World War I now very briefly, because it does have an impact on the development of rocketry and space travel. There we go. So this impact of World War I. World War I is the first total war, and the fact that you have a blockage in the trenches means that you have both sides, the Allies and the Center Powers, seek the development of new weapons. There's some absolutely horrible ones that we know of nowadays, of course, gas warfare, flamethrowers, but also airplanes and airships, notably used for strategic bombing. Strategic bombing had already existed in some ways in past wars, but it's the first time in the context of total war that the notion that you would hit civilian targets or industrial targets far from the front becomes an accepted method. It goes against the rules of war at the time, but this becomes pretty common. As part of these strategic bombings, of course, how are you going to hit the targets? As of 1917, you do have longer range airplanes who will try and do this. But prior to that, Germany in particular fields Zeppelin airships. not particularly efficient in their bombing, but tremendous psychological weapons. After all, how do you shoot down a Zeppelin? And you have to imagine this small airplanes going up, trying to meet them. The famous was it one World War I aviator who left oral testimony in French archives, said, I saw this thing as I was climbing up towards it, and it was, as long as going from Place de la Madeleine to Place de la Concorde. He exaggerates a little bit, but in fact, the sense of mass, how do you shoot this down with a plane with little cannons? Well, even if you hit a hydrogen bag, it's not going to explode automatically. Okay, what you need is, in fact, incendiary rockets. And so this is a paradox, is in World War I, you have the rediscovery of these early rockets, principles of early rockets. It's developed by a Frenchman named Le Prieur and installed on British aircraft. That the idea is to try, in fact, and shoot down German blimps and possibly German airships. The success rate is mitigated. It's not great. The interesting thing is that these rockets are, in fact, very much inspired from a British model of the early 19th century, the Congreve rocket. Those of you who are familiar with the American anthem, the line, "The rocket's red glare," refers, in fact, to these rockets that were shot by British troops at the fort, the American fort that they were trying to take down. So there's just for the anecdote. Anyway, these rockets are in use. They're a form of artillery, but basically the military is not really interested in those details. Aviation is still very much a peripheral weapon in World War I, even though, of course, its impact will become fully understood within years. The other impact of World War I that has an influence on Germany in particular is the Versailles Treaty. It's an unequal treaty. Germany does not get to have any say in it, okay? And as such, it accepts full responsibility for the war, that it's required to do so. Consequently, as punishment, the German army is destroyed. They're left with a tiny little police force, and they must surrender all their weapons. They keep machine guns, and that's about it. No airplanes, but also, most importantly, no cannons, no artillery. In the context of that treaty, then, there will be attempts by some German military officers who are still have a job to find a way around the Versailles Treaty. If we can't have cannons, can we have something equivalent to artillery, but that's not specifically outlawed by the treaty? And so this will be seeded in the context of Germany. Now, let me talk a little bit about Germany in the 1920s. Germany in the 1920s, there's often this stereotype, saying, oh yes, they lost the war in 1918 and then Hitler showed up. Hitler's alive, but he doesn't show up until 1933. So during these 15 years, what happens in this new Germany, this Weimar Republic? It's a democracy. It's an unstable one. It faces difficulties with extremist movements, of course, the Nazis, but also it's a tremendously glorious era in terms of culture and society, new exploration, new openings of mind, tremendous accumulation of Nobel Prizes. Give you a sense, the Germans are among the first in Europe to give the right to vote to women. France doesn't do this until 1944. So in other words, when we think of the Weimar Republic, we have to think of exploratory longings, among others. As part of these exploratory longings, you have popular culture, of course. And popular culture, strangely enough, becomes interested in rockets. And so you've got this rocket fad in the 1920s during the stable era of the Weimar Republic. As of 1930, it goes into decline. But until then, you have this longing. And so this rocket fad means, you start sticking, for example, rockets, some liquid, some solid, in the back of a car, as you can see here. Or you get together on a Sunday afternoon and you try to mix properly, some liquid fuel and see if that rocket will take off. Of course, try to avoid having too many beers before doing that. And yes, sadly, there were injuries and there were deaths as a result. But still, these intrigued scientists and these enthusiasts who are showing up to see these experiments because they're very much public, they, in fact, combine their interests into a form of experience. And this form of experience is going to draw the attention of the German army. Remember, the German army is still trying to find something to do, okay, beyond having secret projects. And so you're going to have this slow transformation of this rocket fad into a rocket program. Um, this rocket program uh, exists, of course, will exist, of course, in Germany. But before we continue with Germany, we have to wonder, are there rocket fads elsewhere? Or is this a typically, uniquely German phenomenon? In terms of popular culture, I would have to say yes, it tends to be more German. However, there are fads elsewhere. You have multiple rocket societies created. United States sees the American Rocket Society. It's not very successful, although it does have publication. It has a following, but it's really more for the people who are focused, who are interested in this. You have the British Interplanetary Society. Um, Fascinating in its legacy. Much of its publications are still very important reading nowadays. Gives you a sense of how advanced, in fact, British interest, British scientific interest was in such matters. Paradox is that the British space program is not very strong nowadays, but the BIS, in fact, sponsored a lot of studies, notably about what it would take to not just travel into space, but, for example, to try and evolve in space. You have some of the very early concepts of a spacesuit, for example. Okay. And then before I move on, I want to talk briefly about the Soviet Union. The Soviet Union in the 1920s and 30s is also a society, of course, in transition, not just because it has undergone this Marxist-Leninist revolution, but also because in the 1920s you still have very much an exploration of society, opening of new realms that did not exist before. And as part of that, you have Russian futurism, which has some parallels to Italian futurism in the arts, new explorations, but also in technology, a fascination with with technology bringing new things, making the masses more equal. It's utopian indeed, but it is worth noting. And it will carry on into the 1930s and then disappear for a while, partly because of the Stalinist dictatorship. What is involved in this? There's notably a whole wave of science fiction being written in Russian. Fascination with the Red Planet, which in terms of popular culture is interesting because after all it is, the Red Society, Soviet Union, trying to explore the Red Planet. And so that's something that registered in terms of popular culture quite a bit. But it's this notion, essentially, as opposed to going west, young man, the way the Americans might have it in the 19th century, is it go up, young man. That's the way the Soviets will have it. And so why talk about this rocket fad? Because it is going to inspire also some of the Soviet rocket scientists in the 1940s and 50s. More on them later. So you have these fads that are elsewhere. But generally, it's true that most people are interested more in aviation than in space. Let's get back to this German rocket program. So you've got the early trends that exist that you see, for example, in the various rockets that are tested. And then, of course, with the advent of Hitler, arrival of Hitler to power in 1933, you have a shift. Okay, so you go from the Nebel rocket, that was one of the last rockets tested by the sort of German Rocket Society, the amateurs that I talked about earlier, and then you have this shift. I want to focus on these two very briefly: the A2 and the A3. Both are the creation of Wernher von Braun, who has been recruited to work for the Army ballistic missile project, the German Army ballistic missile project. And this marks the shift, okay? Because essentially von Braun is now part of the military in 1934, as a civilian, that is. And this is when, of course, the military is now beginning to receive funding from the Nazis. We've got the A2. A stands for aggregate, aggregate, composite, if you will. And then later the A3 in 1937. Okay. This project won't be built. These two represent the shift towards a military program. I'll talk about the German military program next time, because this way we can shift into the Cold War right after and see what impact the German military program had. That at base is what you have happening, is this shift. And where does it initially take place? They initially practiced at a place called Kummersdorf, not very far from Berlin. This is what it looked like about 15, 20 years ago. Now you have, in fact, a shift um, towards trying to find a more discrete grounds. Partly because if you shot a rocket out to Kummersdorf, you never quite knew where it was going to land. For example, in an accident where they hit a police station, not completely by accident actually. But anyway, that sort of gave a sense that there was something else to be done, and it is on von Braun's advice that the German army looks into moving elsewhere, and they will move eventually to Peenemünde in northern Germany. Werner von Braun, what is he up to? He defends his dissertation and publishes it in 1934, and then essentially he disappears to do research. This research is funded, I have to stress this, by the German army. Michael Neufeld from the Smithsonian Institution has done extensive study on the rocket and the Reich. I'll only summarize a couple of his points next time. What I want to do now is try to understand sort of this division of labor. You have basically a competition of services, even at Peenemünde. On the one hand, you've got the German army, in other words, artillery, infantry, who is interested in rockets. Meanwhile, the German Air Force, the Luftwaffe, is not that interested in that. They're interested in rockets, but only if it allows their airplanes to go faster, if you will. And so we have ourselves this sort of strange division of labor, which essentially also means a division of funding, which will probably help explain in part the lack of sufficient funding for the German rocket program in the early 1940s. They'll be constantly competing. It's going to be a battle for priorities, as Michael Neufeld puts it. I'm not going to get into the details here, but they do test, the Luftwaffe does test an airplane with rocket power while in flight, okay? Of course, you have we often think of the V1. V1 is technically not a rocket, okay, but it is a semi-guided missile. They did try one of those at an air show, unclear whether the car ever took off. What I want to talk here, beyond the anecdote, is one example, the Messerschmitt 163 Comet that was used in 1944-45 against attacking U.S. bombers over Germany. This is a rocket plane, but the analogy to an actual rocket stops here, except for the fact that it uses liquid fuel. Okay, this liquid fuel was particularly dangerous. There is the notorious and sad story of a pilot landing after a test, and a gas tank that was right behind his seat split open, and basically didn't find much left of the pilot after that. He had apparently dissolved in the liquid. But it gives you a sense of sort of the dangers, of course, that these pilots face as they try to go up and shoot down bombers. It's fascinating in terms of its speed, in terms of its aerodynamic shape, but it doesn't do much as far as space travel is concerned or rocket travel is concerned. And this is important. You have basically this division of funding. That means you're putting money into all kinds of ideas that may sound fascinating, but that in fact are not very practical. In some ways, this Nazi scheme of funding various projects, it's a little bit similar to the battle of prototypes that you see in the United States in the 1940s and 50s, or in France even in the 1950s. A policy of prototypes of funding a lot of projects. What you need is a more centralized approach to the concept, to the process. And so this is why, in fact, once the German rocket program accelerates and succeeds as of 1943 or so, this is what is going to be fascinating to the Allies, Americans and Soviets, and a little bit the French and the British, once they come in 1945. But I'll be talking about this in the next session. Thank you very much for listening. I appreciate it.
Thank you very much, Guillaume, for this explanation about space prehistory. You still have the chat, and you can ask some question on it, and maybe we will do another video for next time, and so we will find the answer to your question. Thank you very much, Guillaume. See you next week.
You're welcome.
Guillaume, that was very interesting. I have one question. That's okay for you, Olivier? Olivier, that's okay? Can I ask one question? Okay, so I know you. I know you. You work on the papers, the letters that Albert Einstein wrote during the World War One, and yes, and was he talking about rockets or the conquest of space? Did he say something about that at this time?
In World War One, he focuses solely on his general theory of relativity, which he completes during World War One. He does work briefly on studying aerodynamics of an aircraft for an aircraft manufacturer, a German aircraft manufacturer. It is a temporary project. It seems that he did this essentially for the money. He was asked about a problem and he resolved it. He sent back. He was not interested in it beyond that. He doesn't have. He is aware, of course, of aviation, of space, but he doesn't pay much attention to it. It could also be in part because Einstein, of course, is an ardent pacifist, and even in World War II, in fact, though he initially cedes the idea of the necessity of building an atomic bomb to respond to a perceived German threat, he in fact ends up, of course, opposing the design down the road. So I think you have to imagine Albert Einstein more as what he is, a theoretical physicist interested in many things, but not particularly aviation.
Thank you for watching. Don't forget to subscribe to our YouTube channel, leave us your questions and comments. See you soon!